Right now, as you watch this video, millions of people around the world are downloading files without ever touching a central server. No single company is storing those files. No single machine is sending them out. The data is flowing directly between everyday computers. Yours, mine, your neighbors, all sharing pieces of the same puzzle at the same time. That is peer-to-peer architecture. And once you understand how it works, you will see it everywhere. In the way Bitcoin operates, in the way Windows updates itself, in the way large files can be downloaded faster by more people at once. Let us break it all down. Most of the internet you use every day follows a straightforward model. You type an address into your browser. A big server somewhere in the world receives your request. It sends back the web page. You are the client. The server is in charge. That is called the client-server model. It works really well for most things. But it has one weakness that matters a lot at scale. The server is a single point of control. If the server goes down, the service stops working for everybody. If too many people send requests at once, the server struggles to keep up. The bigger the demand, the more expensive and complex the server needs to be. Peer-to-peer architecture solves that problem in a fundamentally different way. Instead of having one big server in the middle, every device in the network is treated as an equal. Every device can both ask for data and provide data. There is no boss machine. There is no single point of failure. The network itself is the service. Let us look at exactly how peer-to-peer networks operate. Imagine a group of 10 friends who all want to share a large collection of music with each other. In a client-server setup, one friend would have to store all the music on their computer, and every other friend would have to connect to them whenever they want a song. If that one friend goes offline, nobody gets any music. In a peer-to-peer setup, each friend stores some of the music. When you want a song, the network figures out who has it and you download it directly from them. You might even download different pieces of the same song from 3 different friends at the same time, combining them into the complete file. You are a downloader and an uploader simultaneously. That is the core idea. Each participant is called a peer or a node. Each peer can initiate a data transaction and also complete one. As more peers join the network, the total storage and bandwidth of the network grows. Popular content actually becomes easier to get, not harder, because more people are sharing it. This is the opposite of what happens in a client-server model, where popular content creates a bottleneck at the server. Not all peer-to-peer networks are built the same way. There are 3 main types, and understanding them helps you see why different systems make different design choices. The first type is the centralized peer-to-peer network. This might sound like a contradiction, but it is not. In this model, there is a central server, but it only does one job. It keeps an index of which peers have which files. The actual data never passes through the central server. When you want a file, you ask the index. It tells you which peer has it, and then you connect directly to that peer to download. The original Napster worked this way. It was fast and easy to search because everything was indexed centrally. The downside was obvious. Shut down the index server and the whole network collapses. That is exactly how Napster was shut down in 2001. The second type is the decentralized peer-to-peer network, also called a pure peer-to-peer network. Here, there is no central server at all. Peers connect to each other directly and pass requests around the network like a game of telephone. Nutella is a classic example. The advantage is that there is no single point to attack or shut down. The disadvantage is that finding what you are looking for can be slower and less reliable, because there is no central directory. The third type is the hybrid peer-to-peer network. This is the design most modern systems use. It combines a central index for efficient searching with direct peer-to-peer connections for the actual data transfer. Modern BitTorrent is a hybrid system. You use a tracker or a distributed hash table to find peers, and then you transfer data directly between them. You get the search efficiency of a centralized model with the resilience and scalability of a decentralized one. Now let us look at where peer-to-peer architecture actually shows up in the real world. The examples go far beyond file sharing. The most famous example is BitTorrent. When you download a large file using BitTorrent, your client connects to dozens or even hundreds of peers simultaneously. Each peer sends you a different piece of the file. The more people downloading the same file, the more pieces available, and the faster the download. This is why BitTorrent handles large, popular files far better than a single download server. The second major example is Bitcoin and blockchain technology. Bitcoin is built on a peer-to-peer network of thousands of nodes around the world. When you send a Bitcoin transaction, it gets broadcast to all those nodes. The nodes validate and record the transaction without any bank or company in the middle. The blockchain is the shared record that all those peers maintain together. Remove any one peer, and the network keeps running. There is no headquarters you can shut down. Here is one that surprises most people. Microsoft Windows uses peer-to-peer technology to deliver operating system updates. The system is called delivery optimization. Instead of every Windows computer downloading its update directly from Microsoft servers, computers on the same local network, or even across the broader internet, can share update files with each other. According to Microsoft, this reduced the internet bandwidth needed to push updates by 30 to 50%. Your computer is quietly acting as both a downloader and an uploader every time Windows updates. Content delivery networks also use peer-to-peer principles in their architecture. Streaming platforms and large-scale software distribution services distribute the load across many points to avoid a single server becoming the bottleneck. The closer a peer is to you geographically or in network terms, the faster the data can travel. Finally, decentralized communication tools have grown significantly in recent years. Applications that prioritize privacy and resistance to censorship often use peer-to-peer architectures to ensure that no single company controls the flow of messages. Peer-to-peer architecture has some clear and powerful advantages. Let us run through the main ones. Scalability. As more peers join, the network gets stronger, not weaker. Each new peer brings more resources. This is unique compared to the client-server model, where adding more clients just increases the load on the server. Fault tolerance. Because there is no single point of failure, the network can keep working even when individual peers drop out. One machine going offline does not stop the service. Cost efficiency. There is no need to buy and maintain one giant central server. The cost of storage and bandwidth is distributed across all participants. Decentralized control. No single company or government can easily shut down a well-designed peer-to-peer network. This is particularly valuable for systems like Bitcoin that are built around the principle of trustless, permissionless access. But peer-to-peer architecture also comes with genuine challenges. Security is harder to manage. In a centralized system, you protect one server. In a peer-to-peer network, every peer is a potential entry point for bad actors. Sybil attacks, where one bad actor creates thousands of fake peer identities to manipulate the network, are a known threat. Quality of service can vary. A peer-to-peer network is only as good as the peers participating in it. If peers are slow, unreliable, or offline, performance suffers. Legal and regulatory complexity is real. The history of peer-to-peer networks includes many legal battles over copyright infringement. Because content flows between peers rather than through a controlled server, it is much harder to enforce what is and is not shared. Peer-to-peer architecture is one of the most important and underappreciated ideas in computing. It powers the files we download, the cryptocurrency transactions we make, and even the operating system updates running silently in the background on hundreds of millions of computers. The central idea is elegantly simple. Instead of one machine serving everyone, everyone serves each other. The network is the service. Now, here's a question for you. Can you think of an app or service you use regularly that might be using peer-to-peer principles behind the scenes? Drop your answer in the comments. I read every one. And if this helped you understand the concept, check out the next video on distributed systems, which takes these ideas even further.